Hello everyone, this is the third video for balancing the redox equation, and here we are going to solve this balancing redox equation in basic solution. And equation is cyanide minus in aqueous plus MnO4 minus in aqueous is equal to CnO minus and plus MnO2 in basic solution. So we have to follow some rules to balance this redox equation in basic solution. So basically first we have to use this half reaction method, and second we have to first balance other atoms then hydrogen. So other atoms then hydrogen, so hydrogen and oxygen we balance later. First we balance other atom. Third is balance oxygen atom by adding water molecule, balance oxygen atom by adding water molecule as needed. Third rule is then we have to balance hydrogen atoms by adding hydrogen ions, and then we have to balance electrons as required. And so up to these 4 points, these are the same rule as we have to balance the redox equation in acidic solution. So these are the same rule as we follow in the acidic solution when we balance the redox equation. And there is one more extra rule for the basic solution. We have to add hydroxyl ion OH minus to both sides to neutralize hydrogen ion. So this is the new rule which we have to follow here. So let's see how we will solve this equation. So first we have to write the whole equation in two half reactions. So we can write like this: Cn minus and CnO minus, equation number 1, and then MnO4 equation aqueous to MnO2 solid, equation number 2. So we have to half both the reactions. And then next step, what we have to do, we have to balance oxygen and hydrogen atom. If you will see equation number 1 and equation number 2, basically other atoms are already balanced. One carbon is here, one carbon is here, one nitrogen on this side, one nitrogen on this side, and oxygen is not balanced, so we have to balance here. And manganese, one atom on the left hand side, manganese one atom on the right hand side, both are same. So let's balance oxygen atoms and hydrogen atom first. So what we have to do, so we have to add some extra water molecules. We have to add some extra water molecule in equation number 1. So you can see in equation number 1, on the product side we have one oxygen extra, that is why we have to add one water molecule. And since we added one water molecule in the reactant side, now you can see there are two hydrogen atoms are extra, so we have to add two hydrogen ions on the product side and make it equation number 3. On the other hand, in equation number 2, you can see there are 4 oxygen on the reactant side and 2 oxygen on the product side. So to balance these number of oxygen, we have to add 2 water molecule on the product side, then 4 oxygen will be on product side and 4 oxygen will be on reactant side. So oxygen are balanced, and now we have to balance hydrogen ion. So there are 4 hydrogen atoms on this side, therefore we have to add 4 hydrogen ion on the reactant side. So now hydrogen and oxygen are balanced, and we have equation number 3 and 4. So next we have to balance the charges by adding electrons. So let's see how many charges are here. If we will see equation number 3, we have one negative charge on the left hand side and one negative charge on the right hand side, but there are two positive charges on due to hydrogen ion. So to balance these two, so negative charges are balanced and water is neutral molecule, so zero charge. So to balance two hydrogen plus ion, we have to add two electrons on the reactant side. Now the charges will be balanced by electrons in this case. And what will happen for the equation number 4? If you see equation number 4, there is a 4 plus charge due to hydrogen ion and 1 minus on the reactant side. So total there is extra hydrogen ion on this side, but these molecules both are neutral, so there is no charge. So what we have to do, we have to balance 3 extra electron, we have to add 3 extra electron, then total negative charge will be 4 due to 1 from manganese MnO4 and 3 electrons, so total 4 negative and total 4 positive. So now we have balanced oxygen and the electrons are already balanced. So what we have to do next, so now we have to add, if you see this reaction, that we have extra hydrogen on both sides, so we have to follow the fifth rule in this case. So we have to add hydroxyl ion to balance the hydrogen ion. So in the equation number, if you see equation number 5, there are 2 hydrogen ion on the product side, so to balance the hydrogen ion, we have to add 2 hydroxyl ion on the product side. So we have to add 2 hydroxyl ion on the product side to balance the hydrogen ion, and same time we have to add the same number of hydroxyl ion on the reactant side. So we have to add hydroxyl ion to the both side in the both reactions. So what will happen in the next equation, if you will see equation number 6, in the previous way where we have to solve, there are 4 hydrogen ion on the reactant side and nothing on the product side. So we have to add 4 hydroxyl ion on the reactant side. So we have to add 4 hydroxyl ion on the reactant side and same number on product side. So what we have to do now, we have to neutralize hydrogen ion and hydroxyl ion by forming water molecule. So if you will see that 2 hydroxyl ion and 2 hydrogen ion, if you will combine these two, so they can form 2 water molecule which are here, and on the reactant side there is no hydrogen ion, therefore the hydroxyl ion will remain as such. And in case of equation number 8, if you will see that there are 4 hydrogen ion and 4 hydroxyl ion there. So if you will neutralize these two, hydrogen and hydroxyl ion, you will get 4 water molecule. So you have to add basically you have to neutralize hydrogen ion and hydroxyl ion by forming water. So now what we have to do, we have to cancel the water molecule. Those are the common in the both the reaction, because we have to add equation number 9 and 10 at the end. So we can cancel 2 water molecule from this reaction and 2 water molecule from this reaction. So what will remain here? First we have to cancel individually. Actually, let's talk about the equation number 9. We have to cancel water molecule in the equation number 9. So 1 water molecule is on this side and 2 water molecule on this side, so only 1 water molecule will remain here. So equation number 9 will become Cn minus, OH minus, and CNO minus, plus water molecule, only one water molecule remain, one will be cancelled from this equation number 9, and we have to cancel the water molecule from the equation number 10 also. So 2 water molecule on the reactant side and 2 will be cancelled from here, so only 2 water molecule will remain on this side. So equation will become, equation 10 will become equation 12, 3 electrons plus 2 water molecule and MnO4, MnO2 and OH minus. So I'm giving every equation with the new number so that it is easy to track them. And then what we have to do at the end, if you will see, number of electrons on the equation number 11 are 2 and number of electrons on equation number 12 are 3. So to balance the electron, we have to multiply equation number 11 by 3, then it will become 6 electron, and equation number 12 by 2. So we have to multiply the whole equation number 11 by 2. So then it will become 3 cyanide and 6 OH, 6 CNO and 3 H2O plus 6 electron. So this will become equation number 13, and if you will multiply equation number 12 by 2, so this will be equation number 14. So now we are almost done and everything is balanced. So what we have to do at the end, we have to add equation number 13 and 14. So we are almost everything is balanced, charges are balanced, atoms are balanced, water molecules are neutralized and cancelled. So once you will add equation number 13 and 14, you will get this new equation, which will be our final equation. This will be our balanced equation in the basic solution. So this is our redox reaction we balance in the basic solution, and if you will count that everything is balanced, so there are 3 carbon on both side, 3 nitrogen on both side, 2 hydrogen on both side, 9 oxygen, 2 manganese and 5 negative charges on both side. So every mass, so you can see that all these correspond to the mass, and this is charge. So mass and charge both will be conserved in this reaction whenever we balance a redox reaction.